Hi, I'm Scott Flowers with Cloud Ninjas. Today we're here to do a server overview on Gigabyte R283-ZK0-AAL1. Let's get going. Hey, thanks for stopping by today to learn a little bit more about the Gigabyte R283-ZK0-AAL1. Do us a favor, if you find anything that helps you in this video, click that like, smash that subscribe. So this video is going to cover CPU, RAMs, GPUs, drives, network cards, power supplies, plus a bunch more. So let's just go ahead and hop into the CPUs. All right, so let's talk about CPUs. There are two CPUs inside. It is an AMD CPU, which if you know me, you know I love AMD. It's going to be an SP5 socket, which means that's the 9004 Genoa or the 9005 Turin processors. So both are compatible. And people ask all the time, hey, what CPUs do you recommend? And really that depends on your application. So what we like to do is we break it down into our low end, our value, and our high end. And really that's just kind of a way to separate it, because sometimes the low end or the value might even cost a little bit more than one another in a different category, because if you get the F1, that's the faster speed or the frequency. So those are going to be the ones that generally cost more, even if they're in the value or the low end. And those are ones personally that I like the most just because of the speed. But here's a little handy dandy chart. And one thing you will note is yes, you can put in two of the 192 core processors into this box and get a whopping 384 cores of CPU processing power. That's insane. On top of the amazing CPU power, that brings us to RAM. And literally RAM is one of my favorite things about this box, and we'll get to that in a minute. But when you go through and you look at all the different Genoa and Turin servers that are out there, and believe me, we've done it. If you go through all the ASRoCs, the Gigabytes, the Supermicros, the Azuses, Dell, who's already overly expensive and doesn't really normally have a bunch of great AMD options in the first place, but if you go through all of them, you'll notice a common trend that when they switch from Milan over to Genoa and Turin, most of the boxes only have 24 DIMM slots. Now, the reason being, in a lot of cases, they were trying to keep it to 1 DIMM per channel so that you don't clock your speed down for your memory, and I get all that. But when you want to put in a ton of RAM, what box supports a Genoa and a Turin that you can put in up to 48 DIMMs? Well, this is one of them right here, and that's why it makes it one of my fan favorites, because you can actually put up to 6 terabytes of RAM. But now I'm getting ahead of myself, so let's backtrack and let's talk about RAM. So it takes DDR5 memory. There are 48 DIMM slots. That means there's 24 DIMMs per CPU, which does mean it is 2 DIMMs per channel, which does mean the memory will clock down, and we'll get to all that here in a second. But that is going to be the overall just general information about memory that will really interest you. So one other important note before we hop into the speeds is that this uses ECC Registered, known as an RDIMM. When you get to DDR5 world, load reduced is gone, and ECC Registered is going to become the most prevalent with the Genoas and the Turins and the higher end Intels as well, for that matter. So let's talk about the speeds. What speeds are supported? You can go as low as a 4800, you can do a 5600, or all the way up to a 6400. But don't buy the 6400. And you ask me why. It costs more. So if you're not getting the advantage of it, why spend that money? Well, why are you not getting the advantage of it? Because it's going to clock down. So this is going to be a fun little chart that we're going to put up right now for you. Hopefully this will help. So essentially, if you put in a Turin CPU, so the 9005 series, you can get up to 5200 speed if only putting in 1 DIMM per channel. Okay, that's the max speed you can get, period. Now, if you put in 2 DIMMs per channel, which means using all the slots, so if you're putting 2 DIMMs per channel and you're using a single rank module, that's going to clock down to 4400. If you're using a dual rank module, which is probably most likely, it's going to clock down to 4000. That's with the Turin. Now, if you're using the AMD Genoa, the 9004 series, the max you're going to get is 4800. So just buy a 4800 speed module. No point in even buying the 5600 with the Genoas, because they're going to cost less if you buy the 4800, and you're going to save a little bit of money, and the max you're going to get anyways is 4800. Now that is only with 1 DIMM per channel. As soon as you go to 2 DIMMs per channel, it's going to clock down to 3600. So again, no point in buying the 6400 in any of these scenarios whatsoever, because to use the 6400, it's going to clock down to 5200 with a Turin proc and only 1 DIMM per channel. So again, no point in doing it. If you're using a Turin, I recommend the 5600 speed for 1 DIMM per, and if you're using the Genoa, I recommend the 4800 speed, just period. So what sizes are supported? A 16 gig, a 32 gig, a 48 gig, a 64 gig, a 96 gig, or all the way up to 128 gigabyte, which again, that is the coolest part about this box in my opinion. 6 terabytes of RAM. Yes, 48 by 128 gigabyte is going to get you to 6 terabytes of RAM, and that's actually what we were putting in this machine. We had a customer ask us, basically their specs were we wanted a Genoa or Turin CPU and as much RAM as possible, and they preferred to have NVMe, and that was what they wanted. And so when we started digging back into it, we were like, goodness gracious, there really isn't a lot of boxes that have that many DIMM slots that can do this, and this is the one. So if you're looking for a lot of RAM, this is the machine. All right, let's talk drives. So there are 8 drive bays in the front and 4 in the rear. 2 on this side, 2 on this side. So the 8 in the front are tri-mode, which means it can use NVMe, SATA, or SAS. Now do note if you want to use SAS, you do need a hardware RAID controller, and we would definitely recommend using the NVMe because right now NVMe is less expensive than SATA or SAS, higher scalability, and fastest. So NVMe is the real winner, but want to let everyone know what you can actually use. In the rear, it's going to be SATA or SAS for the 4 drives, but realistically you're going to be using SATA because cabling these for SAS are going to be really a pain for RAID, so realistically you're going to be putting 4 SATA drives in the back if you're using them. So again, 8 NVMe in the front, 4 SATA in the back. All right, so what are the compatible interfaces? Well, we kind of went over it a little bit, but let's dive in and then compare them with the speeds and the sizes, okay? So really, there's 2 drives. That's truly it. Now there's 5, but there's 2 drives as a whole. You're gonna have your SATA solid-state drive and your NVMe solid-state drive. Those are the 2 real ones that you're gonna be using. Now, you can technically, like we said, use a SAS solid-state drive, but I can't imagine anyone really using it. And even Gigabyte's spec sheet reflects it because it doesn't even show the max on it because they're like, why would somebody use that? They would just use NVMe, of course. And then you have 2 hard drives that you could technically use, which would be a 2.5-inch SATA hard drive or a 2.5-inch SAS hard drive. But again, Gigabyte didn't even put it on their spec sheet because why would somebody use that? Like 2.5-inch hard drives are so obsolete at this point, it doesn't really make a whole lot of sense. But again, we want to tell you everything you can use. So all that being said, let's go to the 2 real ones, the SATA solid-state drive and the NVMe solid-state drive. So the SATA is going to be 6 gigabit per second, and the NVMe is PCIe 5.0, so that is awesome. So that is going to get you all the way up to 32 gigabit per second. When you basically break it all down, that's essentially what it comes out to. But it's really, I don't like that number sometimes because it doesn't really compare well because technically the PCIe 4.0 is a 16 and that's less than a SAS 24 and it runs circles around that SAS 24, so those numbers don't really line up properly, but it is what it is. That being said, NVMe is going to be the fastest, read and write, the lowest latency. It's just basically the way we recommend going. So as far as NVMe size, it's going to show 61 terabytes is the max. We've seen some people say you can put it in 122. We haven't played around and done it ourselves. If you have, hey, drop a comment down below. But 61 is the max, and then 7.68 for the SATA, even though I wouldn't be surprised if you could drop in like a 15.36. But that is the max for each of those, and those are the real ones you're going to be using. Now, if you go to the SAS, it's 24 gigabit for the speed per second, and then you're going to have the max is 30 terabytes, so not bad, but not as good as the NVMe at 61. And then for the hard drives, for SATA, get ready, 7.2K revolutions per minute, and with SAS, 7.2K, 10K, or 15K. And again, these are spinning disks, so they're going to wear out over time. The ball bearings are going to wear out. They're going to fail. So SSDs are not only just better performance, but more reliable. So all that being said, that's why they're realistically not even on the spec sheet. And then the sizes for those are a whopping 2 terabytes for SATA hard drives and 2.4 for SAS. So again, not a real point in using those hard drives. All right, so one thing we can't forget when we're talking drives is M.2s. There are 3 M.2 slots on board, but let's be careful. So those 3 M.2s are PCIe 3.0. They're going to be NVMe, which is nice, even if they are PCIe 3.0, because most likely people are going to use this for boot drives, and the difference between Gen 3, Gen 4, and Gen 5 for boot drives is really kind of negligible, to be quite honest. But that being said, there is 3 drives. you realistically, though, are probably only going to use 2. One of them is occupied, and if you use it, it will knock out one of the SATA ports up front, so or NVMe ports up front, however you want to look at it. But essentially, it'll knock out one of your 2.5-inch drives up front if you use it. So it's kind of a vice versa thing. If for some reason you just really prefer 3 M.2s, you can definitely do that. But again, then you would only be able to use 7 drives up front. So that's one thing I just did want to point out. It's kind of a strange feature, but it was Gigabyte just giving you the option to kind of go one way or the other, just in case you needed the 3 M.2. So that being said, PCIe 3.0, 3 of them. All right, let's talk RAID. So as far as RAID's concerned, not everyone's going to be using RAID in the system. Some people will be for their applications. We're just going to kind of gloss over it, to be quite honest. What we're going to do is throw up a comparison chart that's going to show you a bunch of the compatible RAID controllers. I did want to note we are a big fan of Grade. Grade is a newer NVMe RAID solution that is out there that we are an authorized partner with. So if you are looking for any Grade, definitely let us know. We also do, Broadcom, LSI, whatever you really need. But all that being said, here's some compatible RAIDs. And that brings us to networking and network cards. So built into the motherboard, you're going to find 2 1 gigabit RJ45 in the back. Not the best, not the worst. That's fine if you're using this at home for some reason, but if you're using this in data center, you're probably going to want a faster speed. And you also have your management port built into the motherboard as well, of course. And the real options for adding network cards, there are 2 OCP 3.0 slots, and there are 4 PCIe slots, assuming you're not using your PCIe slot for a RAID card or something else. Technically, you can put in multiple network cards, so if you wanted to throw in 4 PCIe cards and 2 OCP, you can do all this, right? So the limitation is just really basically the number of slots. But all that being said, those are the total number that you can put in, and that is what is built in. So let's talk about the interfaces and the speeds. So what are your compatible interfaces? Well, you have RJ45, which is just another way of saying Ethernet, SFP, SFP+, SFP28, QSFP, QSFP+, QSFP28, QSFP56, QSFP112, OSFP, fiber channel. Goodness gracious, that's a mouthful. That's a lot of different interfaces that you can use. Well, what about the speeds? You got 1 gigabit, 10, 25, 40, 50, 100, 200, 400. Yes, you can get all the way up to 400. It's a little insane, some of the speeds you can get nowadays. And then if you're using fiber channel, 16 and 32. So those are your speeds. As far as power supplies, you're going to have dual 2700 watt, 80 plus titanium redundant power supplies. And last but not least, we don't forget our software. We love our software, guys. So supported operating systems. Of course, Windows Server, obviously a very popular one. You're going to have a number of different Linuxes, Red Hat, Ubuntu. You're going to have VMware, even though pretty much everyone seems to hate them right now. And, those are the supporting operating systems. We'll throw up a list right now of the compatible ones. Hey, if you made it this far, click that like, smash that subscribe. And if you're looking for a custom-built Gigabyte, Asus, Supermicro, Dell, HPE, please give us the opportunity to earn your data center, your home labs business. We stock a ton of variety, and we have solutions for all sorts of different needs, just like this 6 terabyte box for here, for instance. So please email us at sales@cloudninja.com. Take care, guys. Thanks for stopping by.